So I guess I will start. With your permission, it will be in English. So good day and good morning, everyone. I'm very happy here to welcome you to our first online ever open day at ELSC, which we're holding as planned, almost as planned, despite of the coronavirus crisis. My name is Nili Vershov. I am the PhD program coordinator at the Edmond and Lily Safra Center for Brain Sciences. And let me describe what's expecting us. First, you will meet an introduction. You'll hear an introduction by Professor Adi Mizrahi, ELSC director. Later on will join us Professor Jonathan Levinstein, head of the program, and he will talk and present a very described presentation about our PhD program here at ELSC. Last but not least, you will meet three of our brilliant PhD students, Roisho, Adikol, I think first Adikol, then Roisho, and Lior Tiroshi, who will talk about their own experience here as students at ELSC. I would like to remind you that there will be time for asking questions, so take into consideration. Yet you are free to ask questions during the sessions. Please raise your virtual hand and feel free. And thank you for your time, for joining us. Despite the beautiful weather outside, we're here inside, so let's make the best of it. Adi, please. The stage is yours.
Yeah, okay. Thank you, Nili. Okay, shalom, everyone. Welcome. Like Nili said, I'm Adi Mizrahi. I'm the academic director of ELSC, the Edmond and Lily Safra Center for Brain Sciences. I'm very pleased to welcome you to this open day. I have to admit it's a strange feeling. I was part of many open days in the past, and this Corona open day, speaking to a camera, is a new experience. So let me begin by already inviting you to visit our magnificent center when normal days will return. ELSC is now turning 10 years old. We're 10. We're entering our exciting teenage years. But in fact, the PhD program is 28 years old. It's not 10 years old. And those of you who will join us will join the class of 29, year 29. And I mention these birthdays because the PhD program of ELSC is the foundation of ELSC. It runs very deep with a long history of success. And we and the Hebrew University at large are very proud of the PhD program and the success of our graduate students. Jonathan, which will follow me, will give you the nitty-gritty details that you might want to hear about the program, but I will try to give you just 2 minutes about the spirit of the program. Although I have to begin by describing that brain sciences or neurosciences is an umbrella term, which includes many disciplines. And at ELSC, we focus on 3 disciplines, which we call pillars that we stand on. These are theory, cognition, and biology. And you will hear these terms later from Jonathan and others. But because we believe that these pillars are vital for being a successful future neuroscientist. The first one is theory, which is about understanding the computations of the brain. The bread and butter of theory are the exact sciences, math, physics, computer science. The second one is the cognitive sciences, which are about understanding higher brain function, things like perception, thinking, learning. Here the bread and butter is psychology. And the third pillar is biology, which are molecules, cells. Those are the biological agents that actually do the work in the brain. And during your undergraduate studies, most of you probably received a strong disciplinary background. This is great. Our philosophy is interdisciplinarity. So if you studied physics, be prepared to look to the biology right into the white of the eye. And if you're a biologist, be prepared to dive deep into the math if you join us. Actually, my colleague Idan Segev calls the student of the program the Renaissance students of tomorrow. And we are big believers that our students will rediscover the brain. And I mentioned these different disciplines because being interdisciplinary is not straightforward and also not for everyone. And our goal is to welcome those students that are up to this challenge. We look for students with great potential and big dreams. And in return, what you get is not only the academic substance. It's clear that by the end of your studies, you will be able to speak different languages. This goes without saying, but joining ELSC is joining a family, and we are committed to make you feel at home. We are committed to give you full support when you need it in order to complete the program. And we are committed to help you find your way to fulfill your dreams in science. So if you have big dreams, your place is with us. If you are thinking out of the box, your place is with us. And if you're willing to work hard and share our vision that research can change the world, we want you in our program. So with this, I will finish my welcome and open the floor for questions if you have about the center at large. And so we'll take a few questions, and following me, I will invite Professor Jonathan Levinstein to tell you more about the program. So if you have any questions about the center, this is the time. No questions, I see. Anyone?
There's questions in the chat.
In the chat. Okay, yes. So the question was whether the classes will be in English. The program is in English. The answer is yes. It's an international program, and all the details about the program itself will be given by Jonathan, which will follow me. I was just introducing because the center, because the PhD program is part of the bigger center, which has about 35 laboratories. And the PhD program, again, it's the heart of our center, but there are more activities beyond the PhD program in the center itself. But with regard to the details, I suggest that Jonathan will give us the information. And I think the next question also by Amit will also be answered by Jonathan. So I see that the questions are about the program. So Jonathan, perhaps you can start. And
good morning, and that you can feel free to ask questions at any point in time. I already see that there is a question: can a bachelor degree apply for the PhD program? The answer is yes. This is a direct PhD program, and students with a bachelor degree can and are encouraged to apply. This is an important crossroad for you. I think you all know it, and you have to make you have to ask yourself two questions. One is what to do, and the second question is where to do it. Now, the fact that you came here to this open day implies that you are thinking about graduate studies, but I guess many of you come from different disciplines, and if you studied physics or computer science or biology or psychology or chemistry or engineering, you ask yourself whether you should go and move to neuroscience or perhaps study physics or a different topic. Now, even if you decide that the brain is what you want to study, you have many options, both in Israel and abroad. And what I will try to convince you is that it's very rewarding and very important to study the brain, and that the Hebrew University in general and ELSC in particular are good places to do it. But before doing it, I'd like to share with you my personal history. Because too many years ago, I was exactly in the same crossroad. I studied physics as an undergraduate student, and I had to decide what to do next. It was clear to me that I want to do a PhD, that I'm interested in research, but what kind of research? I enjoyed very much my physics studies, and I liked very much physics, and I still like it. But reading physics papers, I became convinced that really interesting questions today are in biology in general and in neuroscience in particular. And I was looking for a place where I could use the tools that I acquired as an undergraduate physics student. I can use these tools to study the really interesting questions about the brain. And I found myself in this PhD program. Then it was not called ELSC, it was called ICLC, but basically it was the same thing. And what I did was nonlinear dynamics. I applied tools from nonlinear dynamics to study how the brain works, and it was a very rewarding program for me. And one thing led to another, and I found myself today heading this PhD program. So this is my personal story. And I think that the decision to move from physics to neuroscience and to do it here at the Hebrew University in ELSC's PhD program these were good decisions for my life and for my career. So why study the brain, and why study it now? This will be the first part of my short presentation. And why do it in ELSC's PhD program? And then there will be time for questions. So I think that the first question, why the brain is interesting, why we should study the brain, is that it's arguably the most interesting thing in the universe. I'll give you just one example that I found a few days ago. So what I will show you is the effect of electrical stimulation of a particular bundle of fibers that is shown here in this figure. The Latin names of these areas are not important. What you see here in this picture is an epileptic patient that, for diagnostic reasons, electrodes were inserted to her brain. And at this point in time, this bundle of fibers is stimulated. And look at her face. She becomes happy. And when the stimulation is over, she's no longer happy. So by electrically stimulating a small region in the brain, we can change feelings. And I cannot think of a more interesting question to ask. How does the brain work? How does a small electrical current changes our feelings? So what you see here is the effect of electrical stimulation.
Are you laughing because you can't help it, or are you laughing because the feeling?
I'm kind of like laughing because I can't help it. I wouldn't say anything except that it happens every single time you did that one. Alright, we can start the next one now. Sorry. It's a really good feeling. That's awesome. That I still kind of feel like the spine is a little like tight, like I don't really have control over it. But other than that, I can talk slowly. I feel
She's too happy. She cannot frown.
It's really hard. Okay. Can you think of something sad?
Yeah, think of something sad. What are you thinking about that's sad?
I'm trying to think of my daughter's died. Yeah, I can think of memories, but they're not coming up as sad memories.
They don't feel sad
I don't feel sad
right now. Yeah.
right now, but I know that it's a sad memory.
So she cannot even have sad memories as a result of this electrical stimulation. And this is just one example of how the brain, the brain is what we are. And this is why this is the most important, the most interesting question that there exists. But studying the brain is not only interesting, it's also important. All human suffering is originate in the brain. Education, we spend so much time in school and in universities changing our brains. Wouldn't it be great if we could do it in a more efficient way? Today we try to build machines that are based on the same principles that underlie the computation in the brain. Wouldn't it be great if we could build machines that are as intelligent as the brain is? And just talking about economic cost or the value in economic terms of understanding the brain, this is one number that I found in the internet. The cost of brain disorders in Europe alone is something like 1 trillion euros a year. Think about the economic potential of being able to address some of these brain disorders. Okay, so the brain is something that is worthwhile studying, but why now? What's special about these days compared, for example, to the time that I was a student? And I think that we have, in the last decade or so, there were technological advances that are tools that allow us to measure the activity of large number of neurons in behaving animals. In fact, there are some animals in which we can record the activity of all neurons simultaneously, and these kinds of measurements are done here at the Hebrew University. We are now developing tools that will allow us to measure the connectivity in the brain. We can activate silent, specific neurons at specific times in awake behaving animals. We are making a lot of progress these days, and I think this is a good time to join brain research. So this is from the biological side, but also the technologies that are inspired by the brain are now maturing. For example, in DeepMind, we have neural networks that are motivated by principles of how the brain function, that are now able to learn to play chess and learn to play Go and do speech recognition, all the great things that your cell phone allow you. So this is why it's a good time to study the brain. But why in ELSC? So I'll tell you a little bit about the program and the advantages and also the disadvantages compared to other programs for brain study, both at the Hebrew University and elsewhere. So our focus in the program is the interdisciplinarity. So we take students from math, from statistics, from physics, from chemistry, from biology, from psychology, from cognitive sciences, from medicine, from linguistics, from computer science, from engineering, and we turn them into brain scientists, but each of them keeps his or her own strength in the discipline that he or she came from. Our program is international. About a quarter of our students are not Israelis. And what we look for is academically excellent students, students that are interested, that are passionate about research, that are academically excellent. We look for highly motivated students. If you don't really care much about it, don't come. It's not worth it for you. We're looking for people who are interested in the brain, who are interested in cognition. But one thing about our program that is unique compared to other programs is that we're looking for students that are interested in computational approaches as well as computational tools. So a few words about the structure of the program. In the first semester, this is a semester in which students coming from different backgrounds study supplementary courses that will allow them to study the required courses in our program. So students, for example, coming from psychology or biology, whose computational background is not very strong, they will study calculus and linear algebra. And in fact, it is Roy and Lior that will talk to you later that teach these courses. On the other hand, students whose background is physics or computer science or engineering that know nothing about the brain and neurons, they will study a course that is given by Dr. Inbal Goshen. It's an introductory course about the brain, neurons, and biology. Students that don't have any background in psychology, for example, probably these will be physics students or math students, they will study a course, an introductory course in cognition. And these courses will allow our students to take the required courses that take place in the second and third semester. But before talking about the required courses, one course that is special in our program is a tutorial course. So the idea is that in the first semester, we have intimate meetings in 4 or 5 students with one faculty. They meet every week to discuss a particular topic. This allows students to meet faculty and in a less formal environment and discuss science and discuss career and address these kinds of questions. So these are the mathematical courses, and this is the tutorial course that are unique in our program. One thing that I should tell you about the math and mathematical courses, one in calculus and one in linear algebra, that we're considering a possibility of turning these into online courses, allowing interested students to take these courses as early as the summer, before the beginning of the semester, freeing the time to take more advanced courses. We're not sure that we will be able to do it this year. Then in the second and third semesters, students take courses in 5 topics. There are 2 courses in physiology, one given in the second and one given in the third semester. There is a course. There are courses in computational neuroscience, 2 courses, one of which I teach in the second semester. There's an advanced course in cognitive processes. There's another computational course that is more in the direction of computer science, information processing, that is given in the third semester. And there is an advanced experimental course that is called Research Techniques in Neurobiology. And in addition to these courses, students are required to take elective courses throughout their studies. So why so many courses? So the idea behind, as Adi said, the idea behind our program is that understanding the brain requires different approaching the brain is optimally done from different directions, from biology, from cognition, and from theory. And in order to be a brain scientist, you need background in all these topics. And we provide this background to all our students. So we have courses that are more that provide you with background in psychology, in experimental neurobiology, in physiology, in computational neuroscience, and in information processing and learning. So all these courses are compulsory courses, and the other additional compulsory course is a seminar course that is given at the end of the second year, in which students already present some of their research. So after the third year, I should have said it, after the third year, students should find an advisor and start working in a lab. It's advisable to start looking for a lab as early as possible and start working in a lab as early as possible, but you're not required to do it before the end of the third semester. And again, our philosophy is that brain research is interdisciplinary. You need to become an expert in your field, but you need to know enough about all the other fields in order to be able to make substantial progress in brain research. And ELSC provides you with an interdisciplinary community in which synergy of different skills and approaches is achieved. The unique aspect, beyond the interdisciplinarity, the unique aspect of ELSC PhD program is emphasis on computation. So why we emphasize this computational part? Well, first, because the brain is doing computations. If you want to understand how the heart works, you need to know something about pumps and about the flow of blood. If you want to understand how the brain works, you need to know something about computation. The second reason is that the brain is very complicated. The human brains are something like 10 to the 11 neurons and 10 to the 14 connections, and between 1 million to 10 million kilometers of wiring. Now, just to give you an understanding of what 10 to the 11 means, if you would go to, well, you cannot because you are quarantined, all of you, but someday you will be able to go to the beach. So you'll go to the beach with a small truck and you will dig a hole of 10 meters by 10 meters by 10 meters. And you take all the sand, put it in your truck, and then you go home and you will count all the sand particles. This would be something like 10 to the 11. If you will dig a 10-kilometer strip of sand in the beach, you will reach something like 10 to the 14 particles. The brain is very, very complicated, and computational tools help us deal with this complexity. Another reason why we care about computation so much is that today experimental tools yield many, many numbers. And we need computational tools in order to analyze these numbers. You cannot do research in neuroscience, and I think now today in any science, without strong computational tools. And we provide these tools to our students. Okay, we talked about studies. What about what kind of research can you do? So you can do research in the labs of any of the 30 or so ELSC members coming from different disciplines, but you are not restricted, and this is an important thing, you are not restricted to working in an ELSC laboratory. So you can do your research in any of something like 100 or so laboratories at the Hebrew University, in the Department of Psychology, in computer science, in physics, in cognitive sciences, in the medical school. All these places are open for you. You will, as an ELSC student, you can do research in any of these laboratories, and you will be a very attractive student in all these laboratories because you will come with a fellowship that we provide, and I will talk about the fellowships in a second. Another thing is that we encourage joint supervision. Interdisciplinarity is it's a foundation of ELSC, and we view joint supervision, people coming from different faculties, as something very good. I had quite a few students with that were co-advised by me, and people from very different disciplines, from the medical school, from linguistics, from psychology. As a student, I was co-supervised by actually 2 ELSC members, one coming from physics and one coming from biology. We encourage joint supervision. We are, I think, the largest PhD program in computational neuroscience in the world. We currently have something like 120 students, so you will join a large group. Now, we are different in many aspects. We are different in the fact that we focus on computational aspect. We are different in our focus on interdisciplinarity. We are different in the fact that we require our students to take many courses, more than in other places. And the question is it worth it? Is it all worth it? Are we successful? So up to date, 140 students graduated from our program. I see that I have a question.
Jonathan, you have many questions in the chat, but I guess it's good that you go through the
Okay, I will go through the slides, and then I will talk about, I will answer the question. So up to date, we have something like 140 students that graduated. About a third of these are already professors in the academia. And this is a very high percentage compared to any other program in the world. I don't think that the numbers are higher in Harvard or Princeton or Stanford. And about another third of our students are currently postdocs abroad. And I guess that many of them will become faculty in the coming years. The majority of other students that graduated that are not postdocs or faculty are in the high-tech industry doing various things. In Israel, we have representatives in all, I guess, in all universities, but we also have representatives in abroad, in Stanford, in Yale, in UCLA, and many other universities. As a student, you are required to work hard. But we try to give you the best conditions to do the best science that you can. When I was a child, I was told not to talk about money. That's why the title for scholarships, I used a small font, but still I think it's important, and you cannot do science without בלי קמח אין תורה. About 20% of our students receive all kinds of competitive and prestigious scholarships from outside ELSC, in Google, Azrieli, Hoffman, Adams, all kinds of fellowships. But remaining 80% of the students in the first 2 years receive the maximum fellowship allowed at the Hebrew University, which is around 6,000 shekels plus tuition. And after you pass stage A, after you become formal graduate student, we provide 3 more years of partial support, which is on the order of 4,000 shekels plus tuition. But most labs, students receive additional support from the lab. In my lab, all students receive the maximal allowed support, and this totals to something like 8,000 shekels a month scholarships. In addition, many of our students, although not all of them, are teaching assistants, and they receive salary as teaching assistants. As I said, we are doing our best to support our students in any way possible to make sure that they will be happy and that their science will be excellent. We provide academic support, and this implies that if students we provide special assistance to students in need, for example, students that find the math too difficult. So we provide them with academic support during the studies. Later, we provide generous travel grants to all students traveling to international conferences. We support in the first 2 years the participation in the Israeli Society for Neuroscience meeting. We have many international conferences that take place in ELSC, but we also, through another organization called JBC, we support international conferences that are organized by students, which is something that is special, I think, here at the Hebrew University and ELSC. Some students requested to teach special courses. So now we have students that teach specific courses. We have a course, an advanced course in MATLAB, and an advanced course in deep networks that are taught by students. This was their initiative, and we support this initiative. We also have all kinds of semi-academic social support. We have a student council that can do all kinds of organizes parties, but also academic events like writing marathon and group presentation. And any initiative that you bring, we highly support it, because we want to provide you with the best environment to do science. We have a very nice Engedi retreat, annual retreat in Engedi every year, which students both present research but also have a lot of fun. This is a picture from some years ago. And our goal is not that you do your research on your own, because we believe in collaboration, we believe in interdisciplinarity. We want you to be part of a community. And you'll have the community of students that you study with in the same year, but we also a larger community, and we do our best to operate as a community. As part of the community, we also do volunteering work in and around Jerusalem, and I think that being a member of ELSC is something that is unique. It's not just being a student that you go to work in your lab and then you go home. You're part of a community. And those that will join us will join this community. So I will stop here to answer questions. And I see that there are many questions. Is ELSC more towards basic science or applied science? It depends. It depends on the lab in which you work in. But the majority of labs are doing emphasize or are more interested in basic science and not applied science. Should I first get a confirmation from the lab I'm interested in before I apply to the program? No, you don't need to. You don't need a confirmation. You don't even need to have a lab in mind before you apply. You have plenty of time to find the lab in the first 3 semesters. Can you tell us a bit about what your graduates do today? So as I said, about a third are faculty in universities, about a third are postdocs. I would say of the remaining, most of them work in the high-tech industry, many of them in brain neuroscience related fields, some in more in data science. So this is what people are done. this is what our graduates do. שיעורי השלמה בסמסטר ראשון מתקיימים בעברית או באנגלית? All teaching in ELSC is done in English. Sorry? I have an MA in education. I've been working as an educator. Can I apply with MA in education? This I need to see the CV in order to and discuss this question in person in order to answer it. Are the courses happening in parallel with lab research? Lab research is done, well, after the first 2 years, most of the time is devoted to lab research. Typically during the first 2 years, you do your courses, and if you have time, or you find time also to do lab research, but most of your time is devoted to coursework. Are scholarships in the written amount given monthly or once an academic year? They are given monthly. Can one work outside university during stage A and still get a scholarship? I don't remember the answer to this question, but in practice, during the stage A, you're too busy with coursework. There's no time to work outside. תהליך קבלה לתוכנית. So you apply to the program. All the details are in the website. You need to send your CV, your grades, and some additional information. There will be interviews. Some of the applicants will be interviewed. This year, the interview, of course, would be an online interview, and some of the students that were interviewed will be accepted to the program. Can I contact the teacher I'm interested in directly? I guess it's a question relates to contacting the lab which you will do your research. Yes, you do it directly. Contacting the teacher is done directly. Can we keep a part-time job? This I answered. can those with bachelors in the humanities or arts apply to the program? The answer is yes, but you need to convince me that you will be able to pass the mathematical courses. I'd like to say a few more words about the application. So when we are looking for students that will that will excel in the studies and that will excel in the research. If you will not excel in your studies and will not excel in your research, then it's a waste of time for you and a waste of time for us. So we're looking for good students. Now, we don't care that much about your background, but what we care about is the question of whether you will be a good scientist. And this is what we will, this is a question that we will address when deciding whether to accept you or not as a student in our program. Student teaching jobs is just at ELSC classes, mostly, but not only. We have students that teach in the computer science department. We have students teaching in cognition. But most of our teaching, most of the TAs teach ELSC. When I say 3 semesters, does it include the summer semester or the first semester of the second year? Talking about the first semester of the second year. Does the undergraduate degree limit what labs I can work in? Yes and no. There's no formal restriction. But if you studied psychology, it will be very difficult for you to convince a computational lab that you are a good enough student to work there. Having said that, my lab is computational and I have a student, an excellent student, with a psychology and a background. So when applying to a lab, you need to convince the lab that you will be a good student in that lab. This is what counts. I also know that in some labs in computer science do take students coming from psychology and biology. So it is a consideration, but it is possible to come with one background and work in another lab. Certainly students coming from a more computational background don't have a problem working in biological and in labs that are more biological or cognitive. How many years is the program? So formally the program is, you have 2 years in which you do most of the studies, more precisely these 3 semesters, and then 3 more years in which we support your you being a PhD program. So total is 5 years. Total, it typically takes students slightly more time than that. I'm working as hard as possible to make sure that that it will not take much more time than that. But typically it takes more time, and then what is typically done is that labs support you until you support you financially until you graduate. Another question about a particular background in design. This is something that I would rather discuss in person with after seeing the CV of the student. Is it possible to join the program after a master's degree in biology? The answer is yes. The downside is that you will still be required to take the compulsory courses in the 5 disciplines. So in that sense, our program will require more courses if you have a master's degree than if you will continue in other programs. But we think that this is essential if you want to become a good or very useful, I wouldn't say essential, but very useful if you become to become a good neuroscientist. And many of our students come with a master's degree. For those that are invited to an interview, how will it take place? The interview takes about 20 minutes of 2 interviewers, and you will be asked about your background and about a particular research project that you've done as an undergraduate student, or if you haven't done any projects, tell us about an interesting question that you find in a course that you studied. Our goal in these interviews is to figure out whether you fit the program, whether we think that you have good chances of passing the courses and becoming a good scientist. But it's also an opportunity for you to ask questions to see whether indeed this is the best program for you. In many cases, I convince students during the interview that in fact there are better programs for them. Job opportunities, I answered. Is it possible to be tested this year and start next year? I guess that the meaning of this question is to start in autumn of 2021. I don't see a point doing it. And if you don't want to start next year, then just apply next year. How many new students are accepted every year? It depends. Some years only a handful of students start, and some years almost 20 students start. It depends on the students. And even an option to have a focus on neurodegenerative disorders. In your research, yes. Once you enter a lab, there will be a focus on something, and we have labs that focus on neurodegenerative disorders. Having said that, you will still be required to take all the compulsory courses, because we think that in order to become a good scientist that is able to ask good questions, you need this interdisciplinary background. Now, as I told you, we are very successful with respect to the number of students that later become faculty. Now, I think that we are successful not because the labs at the Hebrew universities are necessarily the best in Israel. We have very good labs, but also good labs in other universities. And I don't think that our students a priori are necessarily the best students that there are. But providing the students with a particular background that we provide allows them to ask questions that students that focus on one particular topic cannot ask. And this is why our students are so successful. But the price is that you need to take all these courses. Does the program allow me to take additional courses without charge? Yes. And we encourage you to take courses. We encourage you to take courses in the physics department, or in the computer science department, or in the biology department, or the psychology department, things that you think are relevant to your research as part of your supplementary courses. When I was a student 2,000 years ago, I basically took all the required courses for the physics graduate program, being part of the ELSC program. We're very rigid about the compulsory courses, but the additional courses that you take, we are very flexible. We also have specific courses in ELSC that are not required but highly recommended in different topics, and we can discuss it if you are interested. Is it possible to start the program in the second semester? It is not completely impossible, but it's highly non-recommended because you will not be able to take the supplementary courses that are required for the compulsory courses. So you really need to convince me, you will have to work hard to convince me that that you can that you will be able to take the compulsory courses before I allow you to start in the second semester. How many people start the program every year? As I said, it varies between 8 to 20. If I'm finishing my BSc this year, can I apply? Yes. When the interview held, you need to sign up to the program before the interview. No. Will the interview be conducted in English? Only if you want to, but most interviews are conducted in Hebrew. What sort of neuro imaging machinery is available in ELSC? I'm not doing neuroimaging. Maybe this is a question that Adi should answer. Adi, are you still there?
Yes, I'm here. ELSC has a state-of-the-art imaging center with a fMRI system. Many laboratories have EEGs, and we also have a modern state-of-the-art microscopy center. So it depends. When you say neuroimaging, it depends exactly what you refer to, but we are at the state-of-the-art when it goes to facilities and neuroimaging facilities included. Back to you, Jonathan.
What are the recommended courses? So in the beginning of the year, I have a personal meeting with each and every student, and we discuss the recommended courses, depending on the background, depending on the areas of interest. Is it possible to work in some of the labs prior to the program? Yes, we actually have a lab rotation course. It's not compulsory, but it is recommended, and you can work in several labs before deciding where to go and get credit points for that. When I need to take the math classes of semester A, if I already accomplished them as a part of my computer science studies, the answer is no. It's not compulsory. Having said that, I strongly recommend that you will look at past year's exams to make sure that you know the material. Sometimes we find that even students with computational background have lacunas in the thing that they should know and they don't know. So it would be a good idea to test yourself, and in some cases, if you find that you don't know enough, maybe to take the course or to take parts of it. But it's not compulsory. Does it mean that April 22nd registration deadline is no longer holds? This is a question that Mili should answer. I don't remember what are the dates.
We didn't do any changes. It should be still April 22.
Oh, I think that I did not understand. I think that I did not understand the question. In retrospect, I understand that I didn't understand the question about the interview. So you apply, then you are invited to an interview, and then we tell you whether you are accepted or not accepted, and then you tell us if you actually want to apply or not. So we don't. You shouldn't feel committed until you are formally accepted, and then it's your decision whether you want to accept it or not. Other joint projects with the industry, there are, but too few. And one of the things that we would like to do more is to have more projects with the industry, but this is mostly done at the level of the individual labs. So it is the individual, it depends on what kind of things the individual lab does. So there's no general answer here. Is cognitive genomics a research area that is explored currently and in particular in ELSC? There are different interpretations to what cognitive genomics mean. There are, many people in ELSC study the genetic basis of different aspects of behavior, not necessarily in humans. But this is something that I guess we should discuss in person. When will the interviews be conducted? Neely, do you remember?
It will be probably 2 or I hope 2 weeks after the Pesach break, but probably it depends on the quarantine, probably through Zoom or Skype or.
How can we find out which labs work with the industry? Usually it's difficult to figure out from the lab sites. That's a difficult question for me to answer. I mean, the reason is that there are, as I said, something like 30 labs in ELSC and more than, I would say 100 relevant labs at the Hebrew University, and I don't follow the research of each and every one of them. So the best way to go is just to ask people. For example, if you go to the lab of Shai Shalev Schwartz or Amnon Shashua from computer science, I'm sure that you can do research that is highly related to Mobileye. They're not the members of ELSC, but for you as a student, it doesn't really matter because you enjoy all of the benefits of being an ELSC student. We don't encourage our students to go to ELSC labs. They can go to any lab at the Hebrew University.
Just a word here, Jonathan.
Yeah.
That we often get requests to be directed to a particular topic, and as far as ELSC goes, students are very welcome to ask us what are the content in ELSC labs. I assume this is similar if you write to the dean of computer science or the natural sciences. But as far as ELSC goes, we very often direct people to things that are not very obvious in the website.
Yes, I mean, I agree. If you will ask me in person what I will do, I will answer to my best of my abilities and then direct you to, I mean, when you say industry, this could be a pharmaceutical industry, but it could be also computer science industry. So I will try to direct you to the relevant people who would know more. I just got a request from Mafat to help in a research project. So we have these all the time, but again, this would be something that we will need to discuss in person, the specific industry and the specific questions. Should the CV be in Hebrew or in English? Either way, whichever is more convenient to you. How do we apply to the program? Well, I think that there are specific instructions in the website, and if there will be additional questions, Nili or I
just
can
press
answer.
the apply at our website. There are instructions there. Choose apply at education.
How do we find all the labs, all the relevant labs websites? That's so. If you are interested in ELSC lab, you go to ELSC website, and then you go under researchers or research, and you find all the labs in ELSC. There's another larger community of brain scientists at the Hebrew University that is called JBC, Jerusalem Brain Community, I think. Stands for Jerusalem Brain Community. They have a website, and there you can find additional labs that are relevant. And then there are many people doing neuroscience in Hadassah Medical School. It's a place to look. Cognitive sciences, psychology, computer science, this should cover most of the people who are doing neuroscience-related research, but there are even people in agriculture, in the Rehovot, that are doing things that are related to animal behavior, which are relevant to ELSC. Is there an option to take only part of the program and get MSc degree? The answer is yes, but it's not recommended. So if you take all the compulsory courses and you start working in a lab and you do some research, and after a year or so you decide that actually you're not interested in continuing with your PhD studies, you can write a thesis and submit it and get a master's degree, an ELSC master's degree. I say that I don't recommend it because this will be, you'll work much harder than you will do for a master's degree in any other program. You'll have to take many more courses. So if you're only interested in a master's degree, then it would be more advisable to go to do it in psychology or biology or computer science or physics, and not do it at ELSC. But if you at some point decide that you're no longer interested, there is a way out with a master's degree. After Corona, will it be possible to make lab tours in order to get motivated? How?
I think there won't be time anyway, because deadline for registration will be before that. So you'll have to submit your application before anyway. Jonathan, perhaps we should move a bit on with our PhD students who are waiting to talk about their experience, and then we will continue with questions.
I'll just answer the three remaining questions that I'll answer these questions. What should the essay in the applying form include? A few paragraphs or less than 1 page explanation to why do you want to apply to this program? What's your motivation behind coming to this program? Can you talk about the Gatsby program? We have, I will very briefly, we have many international collaborations. One is a 3-center Gatsby program in computational neuroscience. Every year we have meetings between ELSC, Columbia, and UCL in computational neuroscience. But we also have other collaborations. Is there a substantial animal experimentation component in the compulsory academic training? There is one course, a lab course, in which you do animal experiments. This is, well, there are two things. One is in the supplementary biology course, you will dissect a brain of a cow. And there are animal experiments in the compulsory experimental course. But I think that those that are not interested do not need to actually touch the animals. I need to verify it, but you do need to be there and see what's going on, and then analyze the data.
It's mainly observation, Jonathan. Even in the methods course, they join an ongoing experiment that is done anyway in one of the laboratories and analyze the data and just get closer to a real experiment.
I will stop here, and we will move to the students, and then you'll have time to ask questions after the students' presentations.
Okay. So hi. Just a second. Okay. Hi, my name is Adi Kol, and I'm a PhD student here at ELSC. So I will talk a bit about my background, what I'm doing today, and later on feel free to ask questions. And don't worry, Neil will also pass you the email of me, Lior, and Roy, so you can even ask later on more questions. So a few years ago, I finished my bachelor's degree in biology and brain science. And I was quite at the same crossroad as you are now. I was really passionate about neuroscience, but I had to choose the right PhD program for me. So why did I choose specifically ELSC? Well, there are actually quite many reasons, but the main of them was the computational aspects. I was really curious about the computational aspects in neuroscience. And already back then, I think that I really realized how much the computational aspects are really, and the computational tools in neuroscience are really important and actually quite mandatory in becoming a neuroscientist these days. So it's really actually quite critical aspect. So what I was searching for is actually a program that from one hand will provide me these computational tools, and from the other hand will advance my biological background, will take me to the next level. And indeed, ELSC offers top-rated courses. Undoubtedly, it's both in computational neuroscience, such as neural networks and models and information processing and statistics, and also unique biological courses, such as that focus, as Jonathan started to mention, on neuroanatomy and advanced techniques in neuroscience, and I will elaborate about it very soon. But what am I doing today? So today I study really unique and fascinating cells in the brain that are called astrocytes. They call astrocytes because they have beautiful star-shaped, they are beautiful star-shaped cells. And what I study is, well, the reason that I study them is that for a long time, the scientific community actually thought that these cells don't really do a lot. They didn't understand really their function. And what I do is study how these astrocytes can contribute and integrate into the electrical language or the electrical code in the brain. And as Jonathan showed before in the movie, you can really see and sense how the electricity in the brain actually creates all the magnificent abilities that the brain can do. So the electric language or the electric code of the brain is extremely important. So what I'm studying is how these astrocytes contribute to this electric coding, and specifically the electric code of creating memories. And this is why I've chose to be co-supervised both by Dr. Inbal Goshen. Inbal Goshen is coming from the behavior background that relates to the memory part, and also a biological background that relates to the astrocytes. And the co-supervision is with Dr. Mickey London, who is an expert at electrophysiology. And electrophysiology is the study of the electrical properties and the electrical language of the brain. So again, the option of even execute this type of research is possible due to the interdisciplinary that exists in this center. So far, I've finished two very big projects that I really love. The first of them, I'll give a short description. The first project showed that actually astrocytes can enlarge synapses, so they can really take part in the electrical code in the brain. Synapses are the connection point between the neurons, so astrocytes can enlarge them, and by that, enhance short-term memory. And my recent project that we submitted a day before we went inside the quarantine, so we dodged that one. And the second project is actually on the ability of astrocytes to go all the way. But the idea of the project was to really push the limits or the functional limits of astrocytes and see what they can do. So we discovered that actually astrocytes can affect a global full brain circuits, which is an ability that was really so far thought that astrocytes cannot completely do. So they can do that. And not only that, they do it. And by that, they can also affect and take part in long-term memories. Now, I just want to give one remark about this project that I think about it. This specific project that we've just submitted was possible only due to the Imaging Center of ELSC. The Imaging Center of ELSC have many types of very advanced, really state-of-the-art equipment and microscopes. And this is where I've done my experiments. And the fact that I had free access to all this fortune was really something that was very important and critical for the success of this project. So without it, it was just not possible. In other universities, it doesn't exist. Another thing that I'm doing today is that I'm also TAing in the introductory course in the neurobiology that Dr. Inbal Goshen passed. And the idea of this course is really to make the most direct contact with the system that we are trying to understand in this building, the nervous system. In this course, we are going through from the most basic properties of the brain, like the memory potential, to the full brain itself, the full organ, the full system. And we are doing it in a very thorough way and also in a very interactive way. We combine a lot of labs with the course and a lot of activities, because we really believe that, and we know from experience actually, that when we really take action, when the students really also do the actions themselves, they learn and they understand much better the content and the material. So for example, as again, Jonathan mentioned, we at some point, the climax of the course, we dissect full car brain. Surprisingly, they're very big. And this is a way to learn about the neuroanatomy. So it's very critical to really understand the parts of the brain and what goes where and how it really looks like, and not just like as a picture in the presentation. So this was about the course. I
will interrupt and say that it is so much fun that I joined I think a couple of years ago, I joined this part of the course, because this is really the way of learning neuroanatomy, and I learned a lot from taking part in this course. So it's really great.
Yes, thanks. Me too, actually. Well, I dissected it and you can really see the bundles themselves. So it's amazing. The brain is really beautiful visually, and you can really see it in this dissection lab. And so one thing that I think that might help you in the place that you are now in this intersection of really big and important decision that you need to make. I started when I said that I came to ELSC because I read the technical syllabus. I thought the courses, and I knew that these are amazing courses. This is the knowledge that I need and I want in order to take me to the next level. But I can say from today, retrospectively, that ELSC gave me much more. So really at the beginning when I came, first of all, I went through this intense 1.5 years of courses where I learned a lot and it was amazing. It really widened my horizons and deepened my understanding of neuroscience and gave me, really provide me the computational tools that I really wanted. But later on, you start your research and then you find out something beautiful about ELSC. ELSC is indeed a community. At that point, when you need to start to build your research questions and to start to execute the experiments and what the analysis and whatever you want to do, you have free access to all these amazing experts at the building that you can take their advice and brainstorm and use all the state-of-the-art facilities that exist there. And it opens so many doors and it allows you actually to do really exciting and amazing research at the research stage and also later on at the statistics and the analysis and so forth. But not only that, because I've already finished 2 big projects from the beginning to the end, I can also say that on top of that, after the knowledge and the computational tools and all this toolkit and support and a bit of love that you take from all the surrounding in ELSC, you also get something that is very critical for your success as a researcher, and that is exposure. ELSC emphasizes a lot about organizing conferences, seminars, as you saw at the beginning, the annual retreat, and all of that by bringing the best researchers from all over the world. And these are actually golden opportunities for the students to not only make a fruitful discussion with leading scientists, but also to share their ideas, to share their results, to discuss on them, and that other people will actually, and the important people, will actually be familiar with you as well. So I think this is a huge added value for ELSC. And so this is what I thought to tell, like from all over aspects. If you want, I can, you can feel free to ask questions now at the end of the part after Roy and Lior will talk as well. Also, again, as I mentioned at the beginning, Neely will send you our emails. So really feel free to ask questions even later on whatever you want or need. So if there are no any questions right now, Roy will also say a few words.
Okay, so I'll start while the spotlight is still on you, Adi. So good morning, everyone. My name is Roy, and I will share with you a bit of my experiences in ELSC. So I did my undergraduate studies here at my home. No, it was here at the Hebrew University, and I studied physics and cognitive sciences. And this was really a great combination for me because on the one hand, I got a set of tools from physics and an approach to observing phenomena in the world. And on the other hand, cognitive sciences actually told me which phenomena I should be looking at, what is interesting to study and research, and what actually happens in the brain. So I would say that for me, coming to ELSC to study computational neuroscience was really a very natural choice. It wasn't a hard choice for me. And the fact that ELSC is in Jerusalem, which I love, was also had some contribution, I would say. So for the first year and a half during the coursework, I felt it was a great intellectual experience for me. So I came with a pretty solid computational background, mostly from my physics studies, but being able to catch up on cellular biology and molecular biology was really interesting. And I would say it was maybe one of the best experiences in terms of broadening my knowledge. And as Adi said, in terms of exposure to new fields that I knew very little about. Now, apart from the coursework, I would say that a crucial point to my scientific education in the program was the possibility to participate in international conferences for which we get a very generous support from ELSC once a year. So the travel grants are what allowed me to do this, and being exposed to research that is being done really anywhere in the world, like Hawaii, we went to Hawaii, was a great opportunity. Now, Jonathan mentioned some student initiatives in ELSC, like the student-initiated courses. And I'd like to share with you two other experiences that I've had with student initiation in ELSC. So I would say that ELSC students are really encouraged to promote their own ideas and their own initiatives. And this year I organized together with two good friends from my lab, an interdisciplinary conference with international speakers about brain connectivity. And this was really a unique chance, being able to invite international speakers and bring together the local neuroscientific community from many different universities in Israel. It was a great experiences. And another interdisciplinary initiative, which I've had a great pleasure to take part in, is something called a SEED grant. So this was a grant that me and two fellows from my class, we submitted to ELSC, and we got funding to do our own research with a research question that kind of combines what we do in my lab, as I'll tell you in a bit, and what another lab does. So I'm coming from a lab which studies the human brain using MRI, and this other lab was some lab that studies a region called the claustrum in the mouse brain. So we had a really unique opportunity to combine the knowledge from these two very different fields into one grant and do our own research as PhD students. And now I'm happy to say that in these Corona days, we finally have the opportunity to turn this into a manuscript. So hopefully if this stays for another 2 weeks, we'll be able to submit it. So of course, the main part of the program after the coursework is the research. And I'm doing my research in Aviv Metzer's lab. So this lab is a lab where we develop new methods or new tools and techniques in a field called quantitative MRI. So quantitative MRI is a field in which we study the human brain in vivo, meaning in the living human brain. And I'm specifically interested in the white matter. So the brain is composed of the cortical gray matter, the cortex, and different regions in the brain are connected through white matter tracts. These tracts communicate information from one brain region to another. And surprisingly enough, we still don't know enough about which areas are connected to which other areas through which tracts and what exactly these tracts do. And I would say that my research is kind of interdisciplinary, because what I'm doing is to combine different methods within the quantitative MRI fields and integrate them to create new methods. So I'm developing algorithms that actually help make the mapping of white matter tracts more accurate. And this is what I've been doing in the past few years. And finally, for the past 2 years, I've been giving the course, as Jonathan mentioned, the course on linear algebra for neuroscience for our first year students. And I would say this is an extremely rewarding experience for me. And this is why I really hope to meet you all there when you come to the program. As Adi also mentioned, as Leo will mention in a bit, please really feel free to contact me with any question you might have on the coursework, on my linear algebra course, on what it is to be an ELSC student, what it's like, or any other advice that you feel you might need. So Nili will send you our contact, my contact details. And with that, I would say that it's time to move on to Leo. Leo?
Hi, everyone. I'm Leo, and I'm also an ELSC student. And I got into computational neuroscience by accident. I have a bachelor's in mathematics and linguistics from the Hebrew University. And when I finished my bachelor's, I wasn't sure what I wanted to do next. I knew nothing about the brain. I wasn't thinking about it at all. I really loved math, and I knew that this is the language that I want to speak in my professional life, but I also knew that I didn't want to just exist in the platonic world of math, and I wanted to do something that could potentially have a positive impact on the lives of real people in the real world. So I took some time off. I went to live in Paris for a year, and on my first visit back home, I met with a friend, and he mentioned ELSC, and it sounded like it combined all of the things I was looking for, so I just enrolled. So it was a very spontaneous decision, but it's really one of the best decisions I've ever made. And the first 2 years of ELSC were a very meaningful experience for me, and the most important part was being part of this small group of talented students coming from very different backgrounds that gave us different strengths and perspectives. The courses in the program are challenging, even if you do have a computational background like me, but we were all working together and helping each other, and everyone needed help with something, and everyone had something to contribute. So it was a very exciting time for me, and I was learning a lot, and I felt my mind and my world expanding. And now, 6 years later, when I see the cool research that my classmates are doing and the different paths that each one of us chose, I still feel very proud to be part of this group. And I know that these are people that I can always go to for help or advice about science or about the many mental and emotional challenges that come with being a PhD student. The second very important thing about being an ELSC student is the support that you get here. So first, as a student, there are many opportunities to interact with the center's researchers, and everyone is always willing to discuss with you and give you advice and feedback. Equally important is the support of the administrative staff, and most of all Nili, that is always there to help with any problem with a smile. And that's something that's really, it's not like that everywhere. And in general, it's been my feeling that the entire system is set out to help me be the best that I can be. And if the final big advantage about this program is, of course, funding. So both the monthly fellowship that you get that allows you to focus on your studies and your research, and the travel funding that each student is entitled to once a year in order to participate in international scientific meetings. And I was able to participate in at least 10 international meetings during my PhD, and that's something that I think not every PhD student is able to do. And so what am I doing now? For the past 5 years, I've belonged to Josh Goldberg's lab at the Faculty of Medicine. Josh is an ELSC graduate, but he's not an ELSC faculty, but I was still able to choose him as a mentor for my PhD. And the focus of the lab is the basal ganglia, which is a set of interconnected nuclei that are involved in movement and learning. And this is also the brain area whose activity is disrupted in Parkinson's disease. And in my PhD, I combine experiments with theoretical and computational tools to study the activity patterns of neurons in this brain area in the healthy and Parkinsonian brain. The ability to do both, to combine experiments with computational tools, is very important to me, and it's only possible because of the wide education that I got during the first few years of this program. And finally, another thing that I've been doing in the past 5 years is teaching the program's calculus and probability course. So together with the algebra course that Roy teaches, the goal for this course is to give first-year students that don't necessarily have a very strong computational background the basic mathematical tools that you need to take the more advanced computational courses. And teaching this course is a very fun and interesting experience, and it's also a great opportunity to learn very important skills. So if you decide to join us, maybe I'll see some of you next year. And thank you for listening. And please don't hesitate to contact me by email or any other way if you have any questions about anything. And we hope to see you. So
thank you, Leo. So now I think it's time for additional questions, if anyone have. Okay, there are questions now. Jonathan, you want to answer, please?
Yeah, I'll answer. Two questions. Is it compulsory to teach? No. I see it as a bonus, but it's not compulsory. A question for Roy. Roy, can you answer it?
Let me see what the question is, then I'll be able to answer it.
It's the last one in Hebrew.
Oh, I see now. So let me just translate it. So the question is, if as a graduate from physics and cognitive sciences, can I tell how I ended up in a biological lab? So yes, I can tell you a bit about that. I wouldn't say that we are a biological lab, but maybe we are. We see ourselves as a more computational lab. But the truth of the matter is that I was very interested in studying the human brain. So even though I love mice, I prefer to leave them in the field and study the human brain. I first found it that what I actually want to do was to use more of the conceptual tools, which I found that I got from my physics studies in order to study a biological system. And for me, I think that Aviv's lab was the natural choice because he uses computational methods and algorithms in order to gain new perspectives on this system, the way its anatomy is built, things like that, like the structure and microstructure of this very complex system. So I would say that I'm using the computational tools that I've had from my bachelor and from my ELSC studies in order to study this system, which is, of course, biological, but it's not exactly a biological lab. I'm not sure if I answered, but if I didn't, you're welcome to ask me either directly or just ask another question, and I'll be happy to answer it.
Maybe if I can interrupt, I can also attest. I have a student. My laboratory is a biology lab, and I have a student that learned cognition and physics. And the way into the lab was through this tutorial course that he rotated in the lab. Then he left, he went to another lab, but eventually he came back. And it took him a while, I have to admit, to understand the biological concepts. But now, after a few years in the lab, we are enjoying his mathematical skills, both the mathematical skills and the engineering skills, by the way of building microscopes and new analyses.
Next question, are there labs that focus on non-computational neuroscience? In fact, most labs don't focus on computational neuroscience. And there are labs that are doing molecular biology, and there are labs that are doing cognitive neuroscience, and both within ELSC and outside ELSC, and all these labs are open to our PhD students. However, our focus is providing a computational background to the students. They don't need to work in a computational lab, but we found that these computational tools provide the students with an edge compared to students that don't have these, did not attain these computational tools. Are there labs that focus on music and cognition, or anything to do with music in general? Adi, do you want to answer this question as a co-director?
Yeah, so we have a few labs. For example, Eli Nelken's lab is working on auditory perception. So he has to do, first of all, so he's doing some research on music perception. So the answer is yes. Actually, we also have in one of the courses, we have a course on music and the brain, which is a unique and very successful course that was given. So indeed, I would say we are also well into the music and cognition aspect. And I think the other aspect is psychiatric disorders. So we do have a lab, for example, Hagai Bergman is now starting to look into schizophrenia. And I know that Merav Achisar also is interested in psychiatric disorders. So yes, the answer is yes.
I would like to add that there are many more labs that focus on psychiatric disorders, not only these labs, both within ELSC, but also outside ELSC. If you're an ELSC student, you can go to a lab in Hadassah Medical School, like Lior went, and work there on psychiatric disorders. Are there labs that focus on sleep? Not in ELSC.
Hagai also started to study sleep now, but generally not as a main theme that I know of in ELSC.
More questions?
There was a question about, is there a substantial animal experiment component in the compulsory academic training? So I think this is...
Yeah, I think I answered this one. So you have the dissection of the cow brain, and then you have a methods course, but you don't actually need to insert the electrode to the brain in order to participate in this course, but you will analyze data that was obtained from animal experiments. This we will need to do. More questions? So I would like to thank you all for coming, and feel free to send me emails or any of the other participants in this meeting. But you can also feel free to call, to send emails to other students in the program. If you see an interesting research in one of the labs and you say, oh, I would have liked to do such a thing. How is it? What's the life like to be a student doing this kind of research or working in this lab? Send an email and people will be happy to address these questions. I think the emails of ELSC students appear in ELSC website or in the particular lab's website, and feel free to ask questions. This is an important decision what to do and where to do it. These are important decisions, and they should be as informed as possible. What's my email? I guess it will be the last question. It is Jonathan, YONATAN, at huji.ac.il. It's one of the advantages of being faculty is that you have a nice email, Jonathan at Huji. Okay.
Oh, it's a wrap. Thank you. Shabbat shalom.
Shabbat shalom. Bye-bye.